Well, hello there, amazing students, people. Whoever you are watching this all over the world. This is the video where we get to see the solutions to the previous questions that were shown in the previous videos. Okay, so we have three sets of questions. We have the basic, we have the intermediate, and we have the exam standard. So let's go ahead and we move until we attain that crescendo, starting from the simplest to the not so simple ones. So we have the first question that starts off by saying, find the empirical formula of a compound containing 24 grams of carbon and 4 grams of hydrogen. By the way, carbon has the relative atomic mass of 12. And hydrogen has the relative atomic mass of 1. That will prove to be useful to us as we proceed to solve this question. So step number 1, find the empirical formula. So now to find the empirical formula of a compound, the first thing to do would be to write down the elements. So let me backtrack a bit and show you the rules for those of you who may be watching this video for the first time. So we have a number of rules for finding the empirical formula of a compound. We write the elements, write their masses or their percentages, then we convert to moles by dividing with the atomic mass, and then we divide everything by the smallest. And if it's not a whole number we arrive at, we multiply and keep multiplying till it becomes whole. So let's go ahead and apply all these steps into the question that we just happened to chance upon right now. So we have step number 1 that says write down the elements. What are the elements? We have carbon and we have hydrogen, C and H. The next step would be to write down their masses or their percentages. Now, the values were given to us as masses, so we go ahead and write that down as well. The mass of carbon is 24. The mass of hydrogen is 4. The next thing to do will be to convert those masses into number of moles. How do we do that? We divide by the atomic masses. Now, the atomic mass of carbon is 12, and that of hydrogen is 1. So therefore, this becomes divided by 12, and this becomes divided by 1 as well. So we have the values of 2 and the values of 4. The next step would be to divide by the smallest number. Now, the smallest number among these duo is 2, so therefore we'll divide all through using 2. So this becomes divided by 2, and this becomes divided by 2. We end up having 1, and we end up having 2. So the last step says if they are not whole numbers, the results that we arrive at, we keep multiplying till they become whole. Well, fortunately for us, these numbers are whole numbers. So therefore, the final ratio becomes 1:2. Now, applying that to the elements that we have, it becomes CH2. This is the empirical formula for a compound. Easy peasy. The next question says a compound contains 1 gram of hydrogen and 35.5 grams of chlorine. Find the empirical formula. Pretty easy as well. So step number 1, we go ahead and write down the elements, which are hydrogen and chlorine. Step number 2 would be to write down their masses. Now, hydrogen has 1 and chlorine has 35.5. The next thing to do would be to convert these masses into number of moles. How do we do that? We divide through by the atomic masses. Hydrogen has an atomic mass of 1 and chlorine has an atomic mass of 35.5. So we have divided by 1 and divided by 35.5. The results that are obtained are 1 apiece. 1, 1. The next step would be to divide through by the smallest number, which happens to be 1 as well. So we have divided by 1 and divided by 1. This results into 1 for both elements. So now applying that to our elements, we have CCl. This is the empirical formula for the compound. Easy peasy. All right, so let's go ahead and solve some more questions. In the next section, we have the intermediates. Now, the empirical formula is CH2. The molar mass is 28. Find the molecular formula. The empirical formula is CH2. The molecular mass is 28. Find the molecular formula. So how do we do that? Let's go ahead and check out the rules for calculating or for getting the molecular formula of a compound. You can see the step method. First, we find the empirical formula. Second, we calculate its mass. Thirdly, we divide the given molar mass by the empirical formula mass. And then fourthly, we multiply the formula by that answer. Well, enough said already. Let's go ahead and apply this to this question and see if we can obtain the answer to that question. So step number one is to write the empirical formula. The empirical formula is CH2. Step number two would be to calculate the mass of the empirical formula. So CH2 leaves us with adding the atomic masses of the individual elements. We have carbon, which is 12, multiplied by 1 because it appears only once. And we have hydrogen, which is 1 multiplied by 2 because it appears 2 times in the empirical formula. So altogether, we have 12 plus 2, which is 14 grams per mole. This is the mass of the empirical formula. Step number 3 says divide the molar mass by the empirical formula mass. The molar mass is 28, so we have 28 divided by 14, which gives us 2. And then the final step would be to multiply the empirical formula by the results, which is 2 that we just obtained. And the empirical formula is CH2. When we multiply this by 2, we end up having C2H4. This, my friend, is the molecular formula of the compound. And I hope you're getting massive value for what's being put out here today. And then we have the fourth question that says calculate the percentage of oxygen in H2O. Now we know that the formula for calculating the percentage composition of an element in a compound is given by the mass of the element in the compound divided by the molar mass of the compound multiplied by 100. Now, what mass of oxygen is present in H2O? Okay, let's find out the mass of oxygen in H2O. You can see O present over here. Oxygen has the atomic mass of 16 and it appears only once. So that leaves us with 16 as the mass of oxygen. So therefore, we can put the 16 over here. What's the molar mass of water, H2O? Pretty easy to calculate. We have hydrogen, which has the atomic mass of 1 multiplied by 2, which is the number of atoms or the number of times that it appears, plus oxygen, which is 16 multiplied by 1 since it appears only once. So we have 2 plus 16, which gives us 18. So the percentage composition of oxygen becomes 16 divided by 18 multiplied by 100. So let's punch our calculators. 16 divided by 18 multiplied by 100. That gives us 88.88888. So allow me to just round it up to 3 decimal places. 88.889%. Pretty massive for one element in a compound. That's the percentage composition of oxygen contained in water. And then finally, we have this set of questions that says a compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. Find the empirical formula. So the first thing to do would be to write the elements out, C, H, and O. The second thing would be to write down the percentages or the masses. Now for carbon, we have 40%. We have 6.7% for hydrogen, and we have 53.3% for oxygen. The next thing to do would just be to calculate or to directly convert these values into masses. So for carbon, that becomes 40 grams. And for hydrogen, that becomes 6.7 grams as well. And then oxygen becomes 53.3 grams. What we did was just to take this percentage and convert it into grams. Okay? So the next thing to do would be to convert these masses into number of moles. How do we do that? We divide by the atomic masses of each individual element. So we have 40 here divided by 12, which is the atomic mass of carbon. We have hydrogen divided by 1, which is the atomic mass of hydrogen. We have oxygen here divided by 16, which is the atomic mass of oxygen. So let's go ahead and do that individually. 40 divided by 12 gives us 3.3. And 6.7 divided by 1 gives us 6.7. And 53.3 divided by 16 gives us 3.3 as well. So the next thing or the next step to carry out would be to divide all through by the smallest number. In this case, the smallest number happens to be 3.3, 3.3, 3.3. So let's go ahead and divide all through. The results become 1, the result here becomes 2, and the result here becomes 1. So let's plug in our values. The final step says we keep multiplying to become whole numbers if what we arrived at are not whole numbers. So all these are whole numbers. So we have the final ratio to be 1:2:1. Applying these to the elements, we now have CH2O. This is the empirical formula for the compound. And then finally, we have this question that says the empirical formula of a compound is this NO2. The molar mass is 92. Find the molecular formula. So the first thing would be, or the first step rather, would be to write the empirical formula, which is NO2. The second step would be to calculate the mass of the empirical formula. Okay, how do we do that? We simply add the individual atomic masses. Now, N, which is nitrogen, has an atomic mass of 14. O has an atomic mass of 16. So this becomes 14 plus 16 times 2 because oxygen here, which is 16, appears 2 times. So we have 14 plus 32. This gives us, allow me to punch my calculators, 32 plus 14, that gives us 46. So it becomes 46 grams per mole. That is the mass of the empirical formula. The third step says divide the molar mass by the mass of the empirical formula. The molar mass is 92. You can see it given over here. Divide it by 46, which is the empirical formula mass. 92 divided by 46. That gives us 2. And then the final step is to multiply the empirical formula by the result, which is 2. The empirical formula is NO2. When we multiply this by 2, we simply end up having N2O4. This, my friends, is the molecular formula of the compound. It's been a pleasure showing you how all these questions can be handled using just one simple concept, the mole concept. I hope you enjoyed every bit of today's video. If you did, please do to consider liking this video, sharing it to all your friends who may be interested in the concept of chemistry and are probably preparing for some terminal examination like WAEC, NECO, JAMB, or anything like that. This is David, a high school chemistry tutor for chemistry students, and I hope you enjoyed this. I look forward to seeing you in the next video. Speaking of my next video, we're looking at the concept of the application of all these in chemical equations. It's something I look forward to breaking down for you. I can't wait to see you in the next video. And with that being said, stay blessed.